Yeah, so we were in the notebook I call Going Deeper, and we were actually going again through the original analysis step by step, and looking into how to process the TEI-XML files, how to navigate through the tree, and how to get some metadata from them. And I was emphasizing that actually there is no one general solution, that you have always somehow modify this for particular document, or at least for particular corpus, on the basis of the tag conventions the corpus is using. But so far, I haven't discussed lemmatization and post-tagging so far. I haven't explained these terms in the original run of the analysis, because it's something what needs a little bit more attention. And here is this section on that, which also explains what these crucial terms mean. So lemmatization is a procedure for obtaining the dictionary form of the word in the text. So like if you have a word if you have a word index at the end of a book, basically it should refer to all places in the book where a term is mentioned, regardless whether it is in what form, in morphological form it is. Similarly, it's practical to have the lemmatized version of the whole document, and for most analysis you work with just lemmatized text, or most quantitative text analysis you work just lemmatized text. Of course, there are some models for advanced computational text analysis which do not rely on lemmatized text, like some distributional semantics models like word-to-vec or so, but they in general they require much larger corpora to produce meaningful results. Because if you have a term book and books, so in most applications it's useful to consider them as one, until you have at least two big corpus for which both of them are representative, and you can also look at the difference in meaning of the singular versus plural. So lemmatization is one crucial term here. Post-tagging is a related term, and it means part of speech tagging. In other words, a morphological analysis of the word as you find it in the text. So if you have some term in a second case, or post-tagging tools ordinarily return you a code which indicates whether a term is a noun, in what case it is, whether it is singular or plural, and so on, or complete morphological analysis of that. And you can navigate through this code, for instance, to filter only for nouns, what might be very useful sometime to focus on only particular types of words. Concerning lemmatization and post-tagging, sometimes the tools do both at the same time, but it's not always the case, but sometimes they do. The most straightforward solution is to go to some web applications. I'm speaking now about Latin. Here is this tool called Colacinus, which is quite advanced tool, and you can download this as a MacBook, as a computer application. Yeah, if you have a local installation called Colacinus, you can interface with it. Okay, there are some ways how to work with from shell. Yeah, great. Yeah, so I haven't used it so much at all. I haven't used it at all. But yeah, so there is a solution. The good thing is that you can also approach it straightly from your web interface by using their API. They have application programming interface. So you can form a request. For instance, once you make something like this and run it in your browser, this is the general URL of the API. Here is the term you are interested in, and here is the format of which is returned as an output of this request. You will receive this as a response on your request in the web browser. So, and this kind of request you can easily implement in your application. So, for instance, when we have this document text split, I will output only first 50 words of it. I can take any of these words here and put it here into the URL, and then I just formulate a request like this. Yes, that's correct request, and here I get the response here as an output of my cell. And so this is but it is as a string response text. So, but what's more relevant is that it's actually JSON structure behind. So once I run this, this is the output for this term of the from. So I make a call to this website for the lemmatization. This is the term. This is the output format I'm interested in, and here is the response I retrieve. And here is this is navigatable. So once I have response JSON, I can simply do, yeah, this is what I have, and JSON, and now I can navigate through it. That's a list, so I'm interested in the first element, lemma. Yeah, so this way I navigate through this structure. I say this is a list of elements. Here is the first element, so this is the first option, what this can mean, what the term can mean. And here I say I want the lemma part of it, and the lemma is here. So I first call the first lemma, and then the second lemma, and this gets me here. So through this way, I can write a loop like this one. And I think it should work. Oh, yeah, I have to print it. yeah. So here I use this this logic to use this web API to calling one by one first 10 words in the document I have here and print the first possibility of what the lemma is. Right, so this way I can retrieve all lemmata for the document. But as you can see, it's extremely slow because for each independent word you call to a web server. You can make it somehow faster by using some parallel computing or something like that, but still it's a quite slow solution. So in this case, in doing some lemmatization, it's not ideal solution to work with this API tools. In case of Czech, there is also a tool for doing something very similar to this. Here is a tutorial for that. I use it sometimes, and it takes as an input also a sentence or a whole document, so you can make it much faster than here. Here, I think you can put only a word, or perhaps I'm wrong. I'm not sure. I haven't checked it so much. I haven't tried so much. So. But that's the whole logic of lemmatization. Many tools work similar, and for classical languages, the most common tool in Python for working from Python is this CLTK library, which is called classical language toolkit. It contains language models, and among the language models, there is a dictionary which is used for this lemmatization within it. And this is actually what we applied here above. And it includes a lot of other tools. We are not able to explore more of them. I recommend to go to the documentation and look at what is included. It's quite extensive library. But as I already mentioned in conversation with Johan, I am not so much satisfied with many things they support because yeah, they have quite strange programming style in my view, and the documentation is also sometimes not so much complete, and there is a lot of bugs in it. For instance, they also offer a stop list for Latin, which you can use for filtering for uninterested word in quantitative analysis. So it's just a list you can use once you want to omit some words which are not so much interested in meaning. You can easily extend this list, like writing like this. You will put another 2 words into the list, and you can easily make it more extensive if you want. And here below, what I ran previously is a function which I developed on my own here for the purpose of this. And it's actually for each term in the document, it makes the lemmatization using the CLTK library, and it also tries to do the POStagging. In the CLTK library, lemmatization and POStagging is solved independently, and in my view, the POStagging works very bad. It does not return. It just returns only a very limited amount of words in properly morphological analyzed. I can show you. So again, we can run something like we have here. For each of the first 10 words in our document. Yeah. For word in text split, that means for first 10 words in the document since the beginning in the list of words, make apply this function, which is make the morphological analysis. And yeah, and let's print it. So it's very, I think, very unsuccessful. It's not able to analyze almost anything. I would say, yeah, this is successful. Why is it here successful? Because I do not use lower. Yeah, here it's a little bit better, but still author, yeah. So it's upon you. I'm not a Latinist, so you have to judge on yourself. My experience with working with the same tool in the case of Greek was that I was not satisfied at all. So I decided to turn to different tools and to implement some functions on my own instead of using this blindly. There is probably some option how to parameterize it. LCLTK offers more different tools for morphological analysis, but as far as I have seen, I was not satisfied with any of them. What I do quite often is that, for instance, I am interested only in verbs, nouns, and adjectives. So I choose from this list. I subsequently choose only elements which in the tag itself have starting with n dash, because that indicates that it is a noun. It's here in the function. It's implemented in this way. Yeah, but it's now off. There is a question if I can demonstrate a little bit more, show more things with the stop list. So how to remove things from stop list? Actually, I don't know how to do it in the most straightforward way, best programmatic way. I just wonder. Yeah, so the most straight. I'm sure there is a lot of other solution. Word for word if word in stop list if word is not in words to remove. So here is the original stop list. And here I look at it and say, okay, but I am interested in adhic and on and I do not want to have them on the list. So I define a new list where I put these elements, and then I develop a new list in this form. I call it shorter. And what I do, that's quite often thing you do with list, that for these elements in the yeah, word for word, it's like literally like it's written here. Word for word in this list, original one, if this word is not in this list. Is it understandable what it makes? Yeah. So, and oh, if yeah, no, yeah, I put it too much literally. No, it is not there. If not in, yeah. So you can see that Adit is not here anymore, An is not here anymore, and Ante is here not anymore. Yeah, there is then something like overlaps in set overlap, but it would be a different and more straightforward solution. So here is a message from Johan that Colatinus is quite successful and gives the probabilities if there is more than one solution. I have used Latinus as a reference corpus. Great. Yeah, I think that definitely there have to be much more robust solution than this one returning just first word or something like that. In my own work with Greek, I actually, yeah, I have some configuration there for choosing some preference of nouns or something like that. You can, yeah. My idea is that it would be great to make something which would derive the terms on the basis, the lemmata on the basis of the context. If that it would look at the neighboring words in the list, and according to that, it would decide whether it is a noun or an adjective or something like that. I think that it would be possible to solve it in terms of machine learning, but or something even more simple. So here is a function which puts all these things together, but from this we used only this line, only the lemmata, and yeah, we haven't run it so in this session, or I haven't run it in this session. So it takes approximately 2 minutes. Yeah. Yeah, one option would be, for instance, either to find some workflow for how to establish a communication between your Python environment or in Google Colab and the Colatinus desktop application, or you could just take the documents from here, export them into text files, and use these text files in Colatinus and then import them back to Python. That would be some, not programmatic, but some possible option as well. So this is the same what we have seen. We are still waiting for the lemmatization. I could just put this out. That does not make any sense here right now. It takes a lot of time. Yeah, so we are here. And then here is the same what we have seen previously. We explain it. So I made the picture, the plot bigger. Here is this argument for setting up, for matplotlib, for setting up the size of plots. And yeah, once we have the data in this form, this is the basis of what you might know from anywhere, this word clouds. Python has a package for developing word clouds. You can set up them in many different ways. So here is the word cloud of the terms we have seen right now. So the words which are bigger here have a higher frequency in the text than the rest. I was playing with word clouds for some time, and what was interesting was, for instance, you can set up the colors here according to some another measurement. For instance, there is an algorithm called TF-IDF. We will turn to it later, and it's exactly this. It's that darker words in the word cloud were words which are more specific for the one particular document in comparison to other documents in the dataset. Perhaps we will have time to look into it in the exercise, but I'm not sure right now. So, and here you find some simple commands for how to download this plot into your to your local machine. So this was going deeper. That was the same analysis we did at the beginning, just showing in more detail what is possible. And now I'm not sure how much hands-on it will be. It depends on you. I think that basically you should be able to follow it, and it should be able to run all the scripts as well. But perhaps we will have no time to go through every command in detail.